twice the size of California. That is how much new land begins drying out every single year, not in a model, but in measurements. 2 NASA satellites have spent more than 2 decades weighing the planet's water from orbit, and their verdict, published in one of science's leading journals, uses a word researchers do not use lightly: unprecedented. 3/4 of everyone alive now lives in a country losing its fresh water. 68% of the loss, once you set the glaciers aside, is groundwater, the invisible reserves under the world's breadbaskets. And here is the sentence that should stop you. The drying continents now add more water to the rising sea than the melting ice sheets do. Much of the water being drained fell as rain before the pyramids were built. By the end of this video, you will know whether we are actually running out of water and where the real danger lies. July 2025. A paper lands in the journal Science Advances, carrying more than 2 decades of measurements condensed into a set of maps. Its lead authors include veterans of satellite hydrology, a team long affiliated with NASA's water tracking missions, and its subject is nothing less than every continent at once. This was not a drought report. It was a balance sheet for the planet's land water, and it has been rippling through investigations and headlines ever since. The instrument behind it, NASA's GRACE mission and its successor, GRACE Follow-On, a pair of satellites that have been weighing the water on and under the land from orbit since April 2002, 22 years of continuous accounting, through April 2024. What they track is called terrestrial water storage. Everything, summed. Groundwater, soil, moisture, snowpack, rivers, lakes. The continent's entire water account, read as one number per region, month after month. The findings arrive in 4 blows. 1. The loss of land water since 2002 is unprecedented in the record, the author's own word, in the paper's opening lines. 2. The area of land undergoing drying is expanding by roughly twice the size of California every single year. 3. Once separate drying hotspots have fused into mega-drying regions spanning the northern hemisphere, an interlinking that accelerated after the record El Niño that began in 2014. 4. Strip away the glaciers, and 68% of everything being lost is a single category: groundwater. And the framing line that holds it together. The world's dry areas are now drying faster than its wet areas are wetting. The account is not rebalancing, it is draining. So translate it. Start with who is standing on the drying ground. To be clear about the scale of what those satellites are describing, since 2002, 101 countries have been losing their fresh water. Those countries are home to 75% of the human species. Wherever you are watching this from, the odds are 3 in 4 that the ground beneath you belongs to the losing column. Now read the roll call of the reserves themselves, because the study names them, and the names are the world's dinner table. California's Central Valley, which grows much of America's produce. The Southern Ogallala, the water under the American High Plains breadbasket. The Northwestern Sahara System, the Arabian System, the Tarim Basin, the Indus, the Ganges-Brahmaputra. The North China System, beneath the fields that feed the world's second-largest population. The great breadbasket aquifers of 4 continents, everyone robustly in decline across the satellite record, trends the authors describe as insensitive to how long you run the data. And the map is not holding still. This February, the investigative newsroom ProPublica traced the newest data and found the Southwest's famous hotspot no longer stops at the desert. It now runs through Texas, up the southern high plains, and south through Mexico into Central America. Dry spots that spent the 20th century as separate problems are merging into one, which leaves the strangest finding, the one about the sea. Pumped groundwater does not disappear. It irrigates a field, evaporates, runs down a river, and ends, molecule by molecule, in the ocean. Sum that pipeline across every drying continent, and the arithmetic lands on a sentence that reads like a misprint. The land now contributes more water to sea level rise than the ice sheets of Greenland or Antarctica. The continents are leaking into the sea, from below, which raises the fair question. Groundwater is invisible, it sits under kilometers of rock, on 6 continents, beyond any camera. Nobody can see it, except 2 spacecraft can feel it. Picture 2 identical satellites, one chasing the other around the planet, about 220 kilometers apart. They carry no camera pointed at the ground. Their entire instrument is the distance between themselves measured to a precision finer than a human hair. Here is the trick. When the leading satellite passes over extra mass, a mountain range, a flooded basin gravity tugs it forward first, and the gap between the pair stretches. Over missing mass, the tug weakens, and the gap closes. Fly that geometry over every point on Earth, month after month, and you have a constantly updated gravity map of the planet. And water is mass. When an aquifer drains beneath a farm belt, the ground above pulls on those satellites a little less, and from roughly 500 kilometers up, the pair feels the loss. That is the entire method. Humanity weighs its underground water by its gravity. Regular viewers will recognize the shape. Like the molten core from our magnetic investigation, this system is mapped by its pull, not its picture. The satellites do not work alone. On the ground, millions of well measurements, including the largest global assessment ever compiled, spanning nearly 1,700 aquifers, confirm the story borehole by borehole. Dwindling reserves, accelerating declines. Orbit and borehole agree. And hold the humbling part. Before 2002, no generation in history could read this ledger at all. The drying is old, the witnessing is brand new. So the ledger is real, and the instruments agree. Now open the account itself, because what is being spent was not deposited by us. What exactly is an aquifer and whose water is in it? Start by unlearning the picture in your head. An aquifer is not an underground lake, no cavern with a black shoreline. It is a sponge, water filling the microscopic pores between grains of sand, gravel, and rock, in saturated layers sometimes hundreds of meters thick. A well is a straw pushed into the wet part of the sponge. Pump the straw, and the water table, the top of the saturation, drops around it. Multiply the straw by millions, worldwide, and you have modern agriculture. Now the second unlearning, whose water it is. Much of what fills the world's great aquifers is fossil water. The Ogallala, the reserve beneath the American high plains, filled largely with meltwater from the last ice age and the ancient rains that followed. Water that seeped into the dark before agriculture existed, before the pyramids, before writing. It has been sitting there, in the pores, through the whole of recorded human history. Every irrigation circle on the high plains is drinking from a glass poured thousands of years ago. And now the arithmetic, delivered slowly, because it is the center of this entire story. Across much of the Ogallala, natural recharge, the rain that actually filters back down, runs at ½ inch to 1 inch per year. Pumping, in the irrigated stretches, draws down the equivalent of 15 to 20 inches per year. Read those two numbers together. The water is leaving 20 to 40 times faster than it returns. Since 1950, roughly 330 cubic kilometers have been drawn from this one aquifer, about 1,000 from America's aquifers combined. And the estimated time for nature to refill the mine zones at natural rates, more than 6,000 years. This is not using water. It is mining it, and the study's authors named the mechanism without decoration. Unsustainable extraction for irrigation is drying the land from below. There is one more turn of the screw, and it is the cruelest. Drain certain aquifers far enough, and the emptied layers compact under the weight of the ground above. The land surface visibly sinks. Parts of California's Central Valley have dropped by many meters over the past century, and the pore space itself is crushed shut. That storage is not merely empty, it has gone unrefillable at any timescale by anyone ever. A ratchet inside the ratchet, every click permanent. Now hold all of that against the satellite map from earlier. Hotspots linking into mega regions, 2 new Californias of drying land per year, fossil deposits leaving at 40 times their refill rate through straws that multiply annually. And the question forms itself, the one in every comment section under every headline about this study: are we actually running out of water? It is the right question. So let us audit it the way this channel audits everything against the record, clause by clause. Now, line up the claims. Claim 1. The drying is unprecedented. Tested against the record supported in the strict sense. The satellites show loss rates never observed since the weighing began, dry regions outrunning wet ones, and trends that hold no matter how the data is sliced. State the honesty clause out loud. 22 years is the entire satellite record, a short ruler for a planet. But the well records reach back decades further, nearly 1,700 aquifers deep, and they agree on the direction. 2 independent instruments, 1 arrow. Unprecedented stands with its ruler shown. Claim 2. It is happening everywhere. tested not supported, and the study itself says so. The tropical belts are robustly wetting, eastern Brazil, much of Central Africa, Indonesia. The full picture is redistribution stacked on top of net loss, not a planet drying uniformly, but a planet drying specifically. Under its breadbaskets, its irrigated valleys, its densest demand. That precision matters, because it relocates the problem from everywhere which paralyzes to somewhere which can be governed. Claim 3. The great aquifers are all doomed. Tested, and here the audit turns complicated, and the complication has a zip code. In the southern Ogallala, under Texas and western Kansas, the mining runs at the 20 to 40-fold rates you have heard, with zones 50 to 60% depleted and wells already going dry. Communities there already plan in decades of remaining water, not centuries. And yet, this very spring, a groundwater district in Nebraska sitting on the same Ogallala aquifer measured its water levels essentially stable, above its own management trigger, with no pumping restrictions needed for next season. Same aquifer, two fates. The difference is partly geology. Nebraska's sands actually recharge, and partly something else entirely. Districts that measure 500 wells a year and meter what comes out. Governance, meeting geology. So here is the audit's scoreboard, stated flat. The rate is exactly as dire as reported. The map is exactly as dire as reported. The uniformity is not, and the inevitability is not. Dire is a measurement, doomed is a forecast, and forecasts on this channel get audited, and that gap between dire and doomed is precisely where the verdict of this investigation lives, which leaves the honest version of the fear. Let us take it seriously, and then let us look at what the record actually shows. Here is the most honest version of that fear, and it may be the best sourced fear this channel has ever tested. Start with the rates. Unprecedented across the entire record of the only instruments ever built to measure them. Add the nature of the water. Fossil, meaning spent, is gone for 6,000 years, which for every human purpose is simply gone. Add compaction. Part of the loss is permanent at any time scale, the pore space crushed shut forever. Add the driver, food. Not swimming pools, not lawns irrigation. The one demand civilization cannot negotiate down to zero because the alternative to watering crops is not watering crops. Add the trajectory. The hotspots are not shrinking, they are linking, merging into megaregions across whole continents. And add the reach. 3/4 of humanity already lives on the losing side of the ledger, with the overflow measurably lifting the sea. Every clause in that paragraph is a measurement. Not one is rhetoric. If you finish this stretch convinced the world is running out of water, you are reading the data correctly. The fear is not fringe, it is arithmetic, compounding in one direction. Now the verdict in part 1 is a study that landed this very spring. The same researcher who compiled that 1,700 aquifer assessment of decline went looking for its opposite and found it. 67 documented cases around the world where a falling aquifer was stopped and pushed back up. He sorted the successes into 3 working strategies: find alternative water sources, price and govern the pumping, or artificially recharge the aquifer by putting water back on purpose. The showcase case study is Las Vegas in the driest state in America, now studied not as a cautionary tale but as a recovery. And his conclusion on the record, groundwater depletion is not some foregone conclusion. Understand what that word means for policy. A foregone conclusion invites surrender. A solvable problem demands work. The data supports the second reading. Nebraska's half of the Ogallala is that same sentence written in local well data, the identical rock, under different rules, producing a different future. Part 2 keeps the verdict honest. 67 recoveries stand against nearly 1,700 assessed aquifers. That is proof of possibility, not proof of trend, and this channel will not inflate it into one. Recovery restores water levels, not compacted storage. The ratchet's permanent clicks stay clicked no matter how well you manage. Fossil reserves cannot be recharged back on any human calendar. For the mined southern Ogallala, the realistic future is not restoration but managed decline, stretching the remaining decades and planning the transition off them. And every strategy in that recovery file costs money, political will, and time, which are precisely the 3 things the drying map is spending fastest. Every one of those recoveries happens somewhere with the political will to act, which is exactly the variable the study says matters most, and the one no satellite can measure. So the verdict cuts clean, and it is neither headline. The world is not running out of water, the planet's water is conserved, and much of it is simply relocating from under the breadbaskets into the sea. But specific, irreplaceable breadbaskets are running out of cheap, local, ancient water at rates no instrument has ever recorded, and the proof that the trajectory can bend is not hope or theory. It is 67 case files, published and largely unread. That is not a hopeful gloss on a grim story. It is the grim story's actual structure, a hazard that is real, severe, and in dozens of documented places reversible. Which future a given region gets is not written in the rock. It is written in the rules above it. Because underneath every number in this story, two clocks are running at speeds that should not share a sentence. Look at them side by side. Two clocks. Start with the deposit clock. The Ogallala's water arrived over thousands of years. Ice Age meltwater. Then the slow drip of ancient storms, filtering down through the sponge at a fraction of an inch a year, a deposit measured not in seasons but in geological patience. Empires rose and fell on the surface above it. The whole of farming history, from the first planted seed to the tractor, unfolded over a reserve that no one touched because no one could reach it. The deposit outlasted every civilization that ever stood on its ceiling. Now the withdrawal clock. It started, effectively, within a single human lifetime. After the Second World War, cheap pumps and center pivot irrigation, the green circles you can count from orbit, turned the dry high plains into one of the most productive breadbaskets on Earth. In roughly 70 years, that machinery spent what had taken millennia to accumulate. And the same clock started, staggered by a few decades, over the Indus, the North China Plain, California's Central Valley, the aquifers of Arabia, a geological savings account, meet an industrial withdrawal rate. And then the newest clock of all, the witnessing clock, which did not start ticking until 2002. Every civilization before this one drew its groundwater down blind, with no way to read the balance. This is the first generation in human history that can watch the account in near real time, and the first 22 years of watching returned a single word: unprecedented. Here is the sober frame, cutting both ways. Deep time offers no comfort and no panic. The deposits were never renewable on a human schedule that was always true, pump or no pump. What is genuinely new is not that the water is finite. It is the rate we are spending it, the reach across every continent at once, and the receipts, the fact that, for the first time, we can see the bill as it runs. Which is exactly why the people who run these instruments do not watch for the day the water ends. They watch the ledger. So here is the ledger, and the 4 entries on it, actually worth your attention. So, where does this leave us? Watching 4 entries, and the first is the eyes themselves. The Grace follow-on satellites keep weighing the planet month by month, and a successor mission is in development to keep the record unbroken into the next decade. That gravity record is the master ledger of planetary water. Every year it lengthens, the word unprecedented gets tested again. Keep one eye on whether the instruments stay funded and flying, because the moment this generation stops watching, it hands the next one back its blindfold. None of these 4 is a countdown, each is a gauge. Second, the ground truth. The well measurements the High Plains states publish theirs each winter and spring are the borehole-by-borehole audit of the satellite map. Like the ocean's annual heat number from our earlier investigation, this is the account statement worth checking once a year. And watch it at the district level, not the national one, because this whole story just taught us that the district is where the two fates split. Third, the recovery scoreboard. Whether 67 documented turnarounds become 80 or 100, the managed recharge basins, the pumping markets, the metering districts, spreading one county at a time. Each new case file is a data point that the trajectory bends. Fourth, the sea level bookkeeping. The land's contribution now tracked alongside the ice sheets in the global accounts. Watch whether the drying share keeps climbing, because it is the strangest sentence in modern hydrology, and it updates every year. One practical note, delivered once and without a sermon. In most water-stressed regions, the single largest lever on the ledger is how the water is priced and metered, which means this is one of the rare planetary problems where local decisions made by ordinary water districts move the master number. The vote at a county groundwater board is, in aggregate, a climate instrument. So test the title one last time against everything on the table. Did the world's largest underground water reserves just hit a point no one alive has seen? In the strict sense, yes, and twice over. The loss rates are unprecedented across the entire record of the only instruments ever built to measure them. And the water being spent is older than every living memory combined, banked across millennia, drawn down in a single lifetime, and witnessed, for the very first time, by the generation now watching it leave. Read that carefully, because both halves are load-bearing. The rate is genuinely without precedent. And the timescale is genuinely without witness. No human being before this one had the tools to know it was happening. But here is the reframe, and it is the whole point. The real danger was never a planet running dry. The planet's water is conserved. It is merely moving from beneath the breadbaskets into the sea. The danger is specific regions spending a 6,000-year inheritance on a 30-year mortgage, while the proof that the spending can be stopped sits published 67 cases deep and largely unread. For every civilization before this one, groundwater depletion was invisible until the wells ran dry. This is the first generation that can see the bill while there is still time to act on it. Margin is the whole game here too, exactly as it was over the ocean's heat and the strained grid, a reserve consumed or defended, with no third option. Only here the reserve took 6,000 years to fill, and the defending has to start before the gauge reads empty. The ledger is open now. Blindness is no longer an available excuse. So watch the gravity record's next release. Watch the winter well readings in the breadbasket states. Watch the recovery count climb, and watch the land's share of the rising sea. We will be tracking all of it as it develops.